Difference between numpy.array shape, r1, and r. In numpy, some of the operations return in shape, r1, but some return, r. This will make matrix multiplication more tedious since explicit reshape is required. For example, given a matrix M, if we want to do numpy.m column 0, numpy.ones 1, r, where r is the number of rows, of course, the same issue also occurs column-wise. We will get matrices are not aligned error since M column 0 is in shape r, but numpy.ones 1, r, is in shape 1, r. So my questions are: what's the difference between shape, r1, and r? I know literally it's list of numbers and list of lists where all list contains only a number. Just wondering why not design numpy so that it favors shape, r1, instead of r, for easier matrix multiplication. Are there better ways for the above example? Without explicitly reshape like this, numpy.m column 0, reshape r1, numpy.ones 1, r.
The meaning of shapes in numpy. You're right, I know literally it's list of numbers and list of lists where all list contains only a number, but that's a bit of an unhelpful way to think about it. The best way to think about numpy arrays is that they consist of two parts, a data buffer which is just a block of raw elements, and a view which describes how to interpret the data buffer. For example, if we create an array of 12 integers, then it consists of a data buffer, range something like this. And a view which describes how to interpret the data. Here the shape, 12, means the array is indexed by a single index which runs from 0 to 11. Conceptually, if we label this single index I, the array looks like this. If we reshape an array, this doesn't change the data buffer. Instead, it creates a new view that describes a different way to interpret the data. So after the array B has the same data buffer as A, but now it is indexed by two indices which run from 0 to 2 and 0 to 3 respectively. If we label the two indices I and J, the array B looks like this. Which means that you can see that the second index changes quickly and the first index changes slowly. If you prefer this to be the other way round, you can specify the order parameter, which results in an array index like this. Which means that it should now be clear what it means for an array to have a shape with one or more dimensions of size 1. After the array D is indexed by two indices, the first of which runs from 0 to 11, and the second index is always 0. And so, a dimension of length 1 is free, in some sense, so there's nothing stopping you from going to town. Giving an array index like this. And so, see the numpy internals documentation for more details about how arrays are implemented. 2. What to do? Since numpy.reshape just creates a new view, you shouldn't be scared about using it whenever necessary. It's the right tool to use when you want to index an array in a different way. However, in a long computation it's usually possible to arrange to construct arrays with the right shape in the first place, and so minimize the number of reshapes and transposes. But without seeing the actual context that led to the need for a reshape, it's hard to say what should be changed. The example in your question is, but this is not realistic. First, this expression computes the result more simply. Second, is there really something special about column 0? Perhaps what you actually need is
the difference between r and 1r is literally the number of indices that you need to use. 1r is a 2D array that happens to have only one row. 1r is a vector. Generally, if it doesn't make sense for the variable to have more than one row/column, you should be using a vector, not a matrix with a singleton dimension. For your specific case, there are a couple of options. 1. Just make the second argument a vector. The following works fine. 2. If you want MATLAB-like matrix operations, use the class matrix instead of an array. All matrices are forced into being 2D arrays, and operated as matrix multiplication instead of element-wise, so you don't need dot. In my experience, this is more trouble than it is worth, but it may be nice if you are used to MATLAB.
The shape is a tuple. If there is only one dimension, the shape will be one number and just blank after a comma. For 2+ dimensions, there will be a number after all the commas. Two. Two, 1.
For its base array class, 2D arrays are no more special than 1D or 3D ones. There are some operations that preserve the dimensions, some that reduce them, other combine or even expand them. Other expressions that give the same array. MATLAB started out with just 2D arrays. Newer versions allow more dimensions, but retain the lower bound of 2. But you still have to pay attention to the difference between a row matrix and column 1, one with shape, 1, 3, v, 3, 1. How often have you written 1, 2, 3, I was going to write row vector and column vector, but with that 2D constraint, there aren't any vectors in MATLAB, at least not in the mathematical sense of vector as being 1D. Have you looked at np.at_2d, also _1d and _3d versions? In newer Python/numpy there's a matmul operator. In NumPy, element-wise multiplication is in a sense more basic than matrix multiplication. With a sum of products on a size 1 dimension, there's no need to use dot/matmul. This uses broadcasting, a powerful feature that NumPy has had all along. MATLAB only added it recently.
If you want to see more, please consider subscribing.